So let's get right into it, shall we? We are talking all about Industry 4.0. It's a word that we talk about often here on Webinar Wednesday. And there's a lot of different definitions out there for what exactly Industry 4.0 is. But one term we really like to use is cyber physical systems. So it's this whole idea that everything that's happening in the physical world, in our manufacturing facilities, in our industrial plants, is now being digitized. Smart sensors and smart devices are bringing everything from the physical world into the digital world. Some other terms that you might have heard of are smart manufacturing or this digital transformation. So where do all of these technologies fall? I mean, if you ask anybody to list off Industry 4.0 technologies, they'll have a whole long list. One way that really helps us understand how we put these into perspective is if we think about it with the metaphor of a toolbox. So Industry 4.0 has this whole range of different technologies that are really just tools to help us to create cyber physical systems. So we did a little bit of digging and we came up, we found a list of our own that we really liked from IoT Analytics. So, I mean, if you ask anybody, like I said, to list Industry 4.0 technologies, you'll have long lists, you'll have short lists, but these are some of the key technologies you'll often see. One thing that these have in common is that these are all cyber physical technologies. These are technologies that help us take what's happening in the physical world, use smart sensors, use data analytics, use computing, and pull data and bring it into the digital world. So things like augmented reality, cybersecurity, digital twins, edge computing, etc. Now, there's one technology that's not listed here, and it's a technology that we've actually added to our product list here at Lab Midwest as another solution that we are now providing educators as another Industry 4.0 tool that they can teach their students. So if we were to add a number 18 to this list, we would add 3D scanning. So today I have brought on my teammate, Ivan Manuel. Ivan is our digital business development executive here at Lab Midwest, and he is also our resident 3D scanning expert on the Creaform 3D scanning platform. Ivan, thanks for joining us on Webinar Wednesday.
Super excited to be here. Thanks for having me.
So Ivan, we're going to jump right into it. Can you help us understand exactly what 3D scanning is?
Awesome. So 3D scanning is the process of creating a virtual 3D representation of an object. It could be a tool, it could be a component or a product. And I like to think of it similarly to a traditional 2D scanner, but now you're able to apply that technology, that concept, to a three-dimensional object in order to collect all the digital data that makes the shape of that object.
Yeah, absolutely. And we can kind of see it there on the screen. You know, one thing that's really important to us here at Lab Midwest is that we're not just playing with cool technologies for the sake of technology. We want to make sure that there's real industrial applications. So
Right.
how are manufacturers using this technology today?
So one of the most common 3D scanning applications we see in scanning and software is quality control. Having the ability to measure objects for analysis of the dimensions, this is providing a huge value to industry. Think of a manufacturer that's getting a lot of returns for a faulty component and wants to look into why that is, gather more information on how he can improve that process over time. So he scans that part or scans each return part and compares them to a certified part, and in order to collect the data to identify, weak points and improve that quality and reduce likeliness that that would happen over time. So quality is huge for 3D scanning. Reverse engineering is also very common, allowing a individual to extract all the different dimensions, the sizing, and replicate it and recreate it in a CAD file. For example, a manufacturer needing to rebuild a part for a product that is no longer being manufactured. So now they can scan a part that they have for a reference, and they can recreate that, and they can 3D print it and use it on their production floor, and then save that CAD file for future use. So these are just two general examples of how we're seeing this technology being used in automotive industry, construction, aerospace, healthcare, and of course, manufacturing.
Yeah, absolutely. That's amazing. I mean, we talk about all the time how Industry 4.0 is, it's so much more than just manufacturing, right? It's just bleeding out into, like you said, all these other industries. And we know that there's no job title called 3D scanner. So what are the types of career roles that students who might be exposed to this technology in their education pathway, what are the kinds of jobs that they could have in the workforce that might use this technology?
Yeah, that's an awesome question. And we're seeing a growing market for 3D scanning across every industry. And it's creating a huge opportunity for individuals that are skilled in this application of 3D scanning to fill the gaps in areas like product design, engineering, inspection, quality. And some of the more specific roles would be mechanical design, engineering, electrical mechanical maintenance, quality control, quality engineers, quality technicians as well. And these are just a few examples.
You named a technician, you named engineer, so certainly there's applications for students going direct to workforce out of high school. There's certainly opportunities for students who have a 2-year technical degree, and there's also opportunities for students who are in that 4-year engineering pathway to be able to utilize some of these skills in their careers. So Ivan, I think we've got a kind of an understanding of how this is being used. I think our audience really wants to see what this looks like and dig deep into the technology itself. So I'm going to ask if you can give us a little demo of our Creaform scanner. First, help us understand the actual scanner itself. Is it just like a fancy camera? Help us understand how it works and the components there. And then maybe give us a little demo of how it scans an object.
Awesome. Yeah. Okay. So here is our Creaform Go Scan. This is the scanner that I use for all of the demos that you'll go through today. The first thing you're going to notice are the cameras and all the cool sensors at the front of the scanner. It has 3 high resolution cameras. These are all going to be used for tracking all the different geometry of an object. There's a color camera with 200 DPI, and this is used to differentiate the color textures on an object, as well as all the different components that, from the lights to the dark. It functions with 50 microns of accuracy. It measures in a resolution of 100 microns, which is extremely precise. It's going to have a measurement rate of 1.5 million measurements per second. So this thing's fast. And all of these different components, all of these different benefits work together to create a high quality scan surface. Each side of the scanner, you'll see later in the demo, there is a distance meter. So it tells you when you're too close, it'll light up red. When you're too far, you light up blue. So it gives you all the data so you can optimize your scan. And there's buttons on each side of the scanner that are preset to work with the program or the software that you're using, but you can, in certain cases, specialize that to your specific need. To just sum it all up, the GoScan 3D, the one that I'm using for the demo, is super lightweight, fast, and it's going to be extremely accurate. So now what I'm going to do, we're going to transition and we're going to show you it in action. This is a video that I recorded in our tech center, scanning a part. At the top left, you'll see me actually scanning the part. In the main image, you'll see what the VX Scan software is producing. So it's able to gather all the information from the part, from the geometry, the texture of the part, where the targets are placed on the part if you're using targets. And it tracks, creates positionings that's used to shape out that digital representation of whatever you're scanning. The scanner is emitting 99 different white light scanning lines onto the part, and it's tracking the distortion of those lines with the 3 cameras in order to replicate that surface in the digital mesh.
You mentioned targets, and I'm assuming that's those dots that we're seeing on that part. Can you help us understand what those are used for exactly?
Yeah. The targets, in this case, I use the targets on this part, and they're assisting in triangulating the mesh across the component. So this is just going to increase the accuracy, and it's going to provide a better reference. Think of it like an anchor for the scanner, so it doesn't get lost if the object moves around, if you shift it on the table, or if you need to reorient it to get a better scan. They're great also for if you're scanning a larger surface that doesn't have a lot of geometry, like the hood of a car. In that example, you would use targets on there so you can differentiate the hood of the car from just space.
That makes a lot of sense. Thanks for explaining that. So we've scanned our part. We've got the mesh here in our software. What happens next?
Okay, this is my favorite part. So this is the editing side. So after you get your scan and you get all of the raw data of the component, now you can go in and you can clean it up and you can make it, the 3D model. So I started by creating multiple clipping planes, and that was to get rid of some of that noise that we picked up from the table and the surface area that I was using. And you'll notice that there's still some noise scattered around the part, around the area of the part. That's from my hand when I was turning the table. It was picking up my sleeve a little bit. So what I did was I isolated the part. I deleted all that additional scan data that wasn't associated with that selected area. And now we're ready to kind of go back through, take a closer look at it, fill any unwanted holes, rescan it, and kind of go into that refining process. What you're seeing now is a second scan that I added to this scan, which was the underside of that component. And I was able to just quickly merge them for the purpose of this demo. So now we have our 3D model, and this is a complete scan of that part.
Wow, that's really fascinating.
Yeah.
So you did all of this in the VX scan. What other softwares are available?
So yeah, as you mentioned, I was using VX Scan for that demo, but VX Model is going to be perfect for product development, reverse engineering, and the components of scanning in order to replicate or recreate a tool or a part. VX Inspect, that's going to be oriented towards your quality side, being able to measure parts, check for faults, make sure that it's optimized to standard. VX Track is going to be ideal for, I didn't really go into it up till now, but the Metro scan that works on the end of arm on a FANUC robot, and that's going to provide dynamic tracking and assembly control monitoring for that purpose.
So lots of different things that we can do with that scan once it's been completed, which is part of our conversation today, right? We're talking about this as just another tool in our Industry 4.0 toolbox. So we've created a digital version of this physical item. What do we do with it next? How can we use this with other technologies?
So once we create a complete scan, we now have, we can use all that data we collected and saved in a wide range of advanced manufacturing environments. So the first example, being able to scan to print a 3D part. I kind of used that example earlier, but a manufacturer needing a component that's no longer manufactured, now they can scan what they have, recreate it, and then 3D print that for future use. 3D scanning to create a digital twin, which allows individuals to scan and capture an industrial workflow and then create a digital representation of that work in alignment with the physical system. And all that data from the digital twin can be used for predictive maintenance, reducing costs associated with the operation, and then working towards a zero to no downtime environment, which is huge. And then finally, the last example, scan for inspection. 3D scanning, which provides the ability to recreate digital replicas of a component. On the production line, you can compare the properties in the CAD drawings for quality purposes, and then identify where there's flaws or where certain measurements could be tightened up. And this is huge for improving quality of a production over time, reducing the maintenance costs, and increasing your overall efficiency.
It sounds like there's, some great applications here, and I'm sure our audience will come up with a whole wide range of other applications or their students, very creative. Help us understand, because I know what we saw, what you demonstrate was just one scanner of a whole wide range of educational products that are available through Creaform. So can you help us understand how these scanners are being used in education today?
So there's two educational packages, one for teaching and the other is going to be designed for research purposes. So I'll start with the teaching package. The teaching package is on the left. You'll see it includes three professional grade scanners, the Academia 10, 20, and 50 scanner. And this package is ideal for teaching metrology at the high school level, technical college level, and university level. So it can be integrated into a wide range of areas, science and engineering, applied science, industrial design, natural science. These are just a few. And then it covers everything from product development, production, conformity inspection, um, to reverse engineering, assembly assistance, and all the other skills that work in line with Industry 4.0. Um, Now, the research package on our right, that's going to include the lineup of the metrology grade scanners, the GoScan 3D, the MetroScan 3D, which is my favorite, and the HandyScan 3D scanner. It also includes the Handy Probe, which is the portable CMM. And this is going to be a package typically seen in your technical colleges and your university research programs. So the field of studies are going to be the same, and it's going to have slightly different applications on the curriculum side, but the field of studies are going to remain very similar to what I described for the academia or the teacher package.
And you said the golden word there, curriculum. So, as many of our audience members will know, we don't do anything here at Lab Midwest unless it has curriculum associated with it. So, Ivan, tell us a little bit about the curriculum and what students are learning as they go through the Creaform package.
So as I mentioned, it's going to align with the two packages that I've described before. Their curriculum includes all of the teaching materials that's going to be industry standard, and they cover three main areas: 3D scanning, reverse engineering, and inspection. It's going to provide unlimited web access to all of the lectures, lessons, tools, everything you need to create a really in-depth program for your school or institution. They're designed to teach all the real-life applications and deliver the hands-on instruction. And all of the resources are put together and structured in a way that's easily integrated into any engineering class or lab.
Absolutely. Thank you, Ivan, for showing us the demonstration of this technology and for talking a little bit about the availabilities for our educators. At this time, I would love to transition into Q&A for our audience. If any of our audience members here have any questions about the Creaform platform that they would like to ask live, they could do so now. So like I said, you can use that Q&A button on your Zoom control panel to submit your questions, and we will pose those to Ivan. And Ivan, we have gotten a couple of questions from our audience so far. The first one, to no surprise, because I know this is a new technology for a lot of our educators, but is it difficult to pick up, and are there instructor resources that will help me learn?
Awesome. Yeah, that's a great question. And the system is designed to be easy to use, but Creaform has created an extensive library of resources for the teachers and students to get you up and running as quickly as like in 30 minutes. So all of that's included in the package that you would, purchase with the scanner on the academia package.
Perfect. Another great question from our audience. Are you able to scan shiny surfaces?
Yeah, that's that's a question that comes up a lot. Reflective, transparent, shiny, very extremely shiny surfaces. Those are gonna typically need to be powder coated. So you would spray on a coat, and that's just gonna assist the scanner in being able to, track the different edges of the part you're looking to scan. So you can't scan glass, but if you put a layer of coating over it, then you would scan it very easily.
Yeah, absolutely. Um, Here's an interesting question, Ivan. Are art programs using scanning?
Yeah, that's huge. We're actually seeing that being very popular for art restoration and saving. Yeah, so we are seeing a lot of art programs, design programs adopting this technology as well.
Yeah, absolutely. Here's another question for you, Ivan. And I think this is kind of more of a comment than a question, but I mean, this I think is surprising to a lot of people when they first see this being used. But can you pick up the object and move it around while scanning it and not lose it?
Yes. So that's a good question. And that's what makes 3D scanning so unique. In this case, you would put targets over the object that you're looking to scan. And once you have targets on the object, the um, the scanner is able to anchor on to those points, and you can move it. You can move it in any way, and the scanner still is able to have a reference point. So whether you scan it and then have to come back and refine it later, the scanner would still be able to track that. So in the case of using targets, yes.
Awesome. Yeah, absolutely. Thank you for mentioning that. That's exactly why we have those targets. They're magic.
Yeah.
um, Another great question from our audience: how large of an object can we scan?
Oh, that's a great question. So these scanners, they're going to scan more. I don't have the exact number, but more of personal items like the size of like a square foot area, and then to remain accurate. Because once you start scanning larger items, then you lose accuracy. The Metro scan, that is going to be used for larger areas. You can scan an entire car, you can scan much larger. But the hand scans, to remain the most accurate, you're going to want to stay within that square foot radius.
Yeah, Ivan, that's a great point that you made. Is that it really does depend on the scanner, and you lose a little bit of accuracy over space. And we can certainly provide spec sheets for what the accuracy is for each of those scanners. Um, as Ivan mentioned, I think he mentioned this earlier in the presentation, but that Metro scan, that kind of hexagonal shape, it goes on the end of a Fanuc M20 robot. So I mean, this is just a huge industrial robot arm, and they're using it mostly in the automotive industry to scan entire vehicles, as Ivan mentioned, for accuracy as they're going through the design process. All right, perfect. Ivan, thank you so much for your time today, for joining us on Webinar Wednesday and just sharing incredible insights into this whole area of 3D scanning. I know it's an area of technology that a lot of our schools are picking up on and using, and finding really creative ways to use it across multiple programs, kind of using it whether it's between their industrial arts program or their career and technical education program or their engineering coursework or material design, whatever it might be. There's a lot of uses for this. And we're excited to talk with any of you about it if you're interested. Keep an eye out for the recording in your email inbox, and you can always reach out to us on our website or info@labmidwest.com if you want to talk more about Creaform 3D scanning. That's it for us today. Thank you for joining us, and we hope you have a great rest of your week.